This is a quick look at radian measure. And for doing radian measure, you just need to know these two things. And that will make life a little easier. So you need to know that half r squared theta equals the area of a sector. And then you also need to know that the area of the sector length, so AB, would be, so sector equals r theta, which is different from degrees, but I think in degrees all the time anyway, although I shouldn't, maybe. Look, figure 1 shows sector AOB with centre 0 or O and radius r. The angle AOB is theta radians, and the area of the sector is 11 centimetres squared. Given that the perimeter of the sector is 4 times the length of the arc AB, find the exact value of r. Okay, so we know the area equals half r squared theta, and that means we know that 11 equals half r squared theta, so 22 over theta equals r squared, so r equals root 22 over theta. That's one thing we know about r. So the next thing we know about r is, and I might do this in another colour, living a little. The next thing we know about r is that the perimeter of the sector is 4 times the length of the arc. So we know that r plus r plus r theta is 4 times the length of AB, which is r theta. No, that equals 4 times that. So that means, so that's 2r plus r theta equals 4r theta. So 2r equals 4r theta minus r theta, which is 3r theta. And then, I suppose I could actually get rid of the r's if I divided through by both. So 2r over 3r equals theta. So then let's get rid of that. So we now know that theta equals 2 over 3. Right, last thing you have to do is r equals root 22 over 2 over 3. So that means that r equals root, so that was 22 times 3 over 2, which is 66, so that's 44. So I'm assuming it equals root 44. I might actually just put it into my calculator. So root 22 times 3 over 2 equals root 33. And do I need to write this in some sort of... Oh, no, I just have to say it's root 33, I think. There you go. Now, so I'm not going to do that. After that, ooh, this looks delightful. This is a design for a logo. And in the design, OAB is a sector of a circle with length r. Oh, okay. So we've got two different sector lengths. One's r and one's 2r. And AOF is a straight line. Right, given that the size of angle COD is theta radians, okay, that's the one in the middle, write down in terms of theta the size of the angle at AOB. Oh, it's only 1 mark, and that's because we know that this is 180 or pi. And so to find this one here, we go pi minus theta, and then we divide it by 2. So that's what that equals there. So that's this. And then show that the area of the logo is this. So again, I'm going to refer back to the thing I did earlier. So half r squared theta is going to be how we start this. So half r squared theta. So the area of the logo is going to be, so this bit here, the top bit, or the fan bit, is going to be half 2r squared theta. Okay, that's the first bit. And then the next bit is going to be, oh, I see. So we're going to use